Good morning, my name is Hendrikje Schmidtpott. I work at the University of Kassel at the Institute of Mathematics, and we develop teaching material for our students, mostly students of electrical engineering and computer science. Well, besides teaching material that is just in written form and graded manually, we started to develop stack questions so they can be graded automatically in Moodle. Well, today I want to discuss one of our questions. Yeah, enjoy. So, the question I have in mind comes from calculus. We all know questions with a rather open input. Questions are supposed to give a formula or something like that that has certain properties, and stack is really good in checking on some of these properties. Now we wanted to ask a question about a sequence, and here we want to ask the students to give us a formula for a sequence that is strictly monotonically decreasing in this case. It also could be some increasing function. We have random variables that are about the behavior and the value of the boundary and the boundary kind of itself. Students are supposed to give us some formula. Most students will give us some standard formula like 1 divided by n or n itself, and with a plus or minus or anything. And even if it's a little bit more complicated, then a tutor would be rather fast in telling the student whether this is a correct answer or not. By experience, that is not a problem, but unfortunately we don't have some sort of artificial intelligence here. So Maxima doesn't have any kind of experience, and that makes it sometimes rather difficult for Maxima to find a solution and to discuss the answer of the student. I just want to give you a quick look with Maxima where the problem is. Okay, so let's take a look at our problem in Maxima. With our sequence, we assume that n is greater than 0, which just makes sense. And then we can give Maxima some sequences, for example, the sequence an, which is a cubic sequence, and then we can ask Maxima whether it is increasing or not. So, yeah, tells us this is true. Yeah, that's fine. But there is a different sequence which we use rather frequently. This is the sequence with factorials, and there we get unknown if we ask anything. So actually that is not much of surprise at first, because Maxima just doesn't know how to work with how we usually work with factorials, so they won't evaluate something like this. We can turn this off by some rule, and then from that point on we can evaluate this and also get an answer here. This is fine, and solves some of our problems, but a slight variation will cause trouble. We could just shift the whole thing a little bit, and then we ask whether this is increasing or decreasing, and again we get a noun. So we need to think of something else to evaluate a term with some sort of factorial. So let's just take a quick look at the Moodle question. I guess most of you know the Moodle backend for a stack question. We have the question variables where we define what kind of sequence is asked for. We have the question text with question blocks, so it always passes the right words. Okay, and we have two feedback trees, one for the boundaries, one for the monotonous behavior. Well, okay, and now let's take a look at the feedback tree. We have a long block of feedback variables. There we have defined the different kinds of tests we use. We check for the difference between two consecutive elements. We check the quotient, but to check the quotient we have to find the zeros first, that we don't try to divide by 0. We check the first 10 elements, whether they work or not, and we check, that's the interesting part, we check for some random numbers up to a really big number, whether this element and its neighbor work or not. And so that's a really nice test to tell whether a sequence will be monotonous, increasing or not. And well, yeah, so in this case we try 500 random numbers and up to 20,000. Yeah. Okay. Well, the feedback tree itself, we ask for the difference. That's a little interesting. When we ask for the difference between two elements, if the test develops to true, everything's fine and we are ready. If it's not true, and that's this part, we have to check whether it is false or not, because well, we don't have option 3 undefined in this tree, so we need, if it's false, then we can tell, yeah, your sequence doesn't work. If it's not false and not true, then it is unknown, and then we can check the next test. And so we have to continue with our tests for every test that is eligible correctly. We really need to ask, is it true and is it false? And if it's neither of that, then we continue to the next test. Okay, so a summarization of our feedback tree. We check for the difference of consecutive elements. Then we will check whether the first 10 elements work or not, because we don't want to tell the student that element number 3201 produces an error when the second one already is wrong. So that's step 2. Step 3 is we will check for the quotient, because sometimes Maxima is easier on the quotient than on the difference, but there we have to make sure that there are no zeros. And last step is we take n, for example, 500 random elements up to any number you can think, and check whether element of this number and it's the next element work, or if they produce an error. Yeah, to come to a conclusion, the main problem we had is input of students. Some students don't check whether their sequence is defined or not. So if they want to take the factorial of a negative number, that just won't work. Yeah, that produces an error, and then they get some weird feedback. Yes. Well, we can't allow piecewise declared sequences, because there you might be able to produce wrong answers of our feedback tests. But as far as I know, Stack doesn't allow piecewise declared functions as input. Well, yeah. And we tried to force some sort of false answer when we worked with testing, and well, we didn't find a way that worked, because if we tried to build something with polynomials, then Maxima is able to tell us whether this sequence is increasing or decreasing. But well, yeah, so there is we didn't find a way to generate a input that gives us a false feedback. Okay, the little sad part is that this random test is hardly ever needed. Most students will in fact give us a function that is 1 divided by n, or just n, and it's a negative element. So, well, we did put a lot of effort in this test, but I think it just triggered twice until now, because usually it's just a basic math for Maxima. So yeah, thank you for listening to this talk, and yeah, if you have any questions, feel free to ask.